Hello, this is Chandrakant again. Today we are going to discuss some of the gate questions, previous year gate questions from the two-port network. Let's start. In the circuit shown below, right? Network N is described by following Y matrix. This is your Y matrix 0.1, minus 0.01, 0.01 and 0.1 Siemens. The voltage gain V2 upon V1 is equal to this. See the circuit. The network N is described by this Y parameter matrix. So once it has been given, we need to first write the basic equations relating to the Y parameters. We know that for Y parameters, Y1 is equal to Y11 V1 plus Y12 V2, then I2 is equal to Y21 V1 plus Y22 V2. And from the matrix, you know that Y11 is your 0.1 V1, then Y12 is equal to minus 0.01, so minus 0.01 V2. Similarly, for I2, Y21 is the 0.01 V1 plus 0.1 V2. We need to check the contextual of the question. That means what they have been what the question is asked to do, that is V2 upon V1. How I can get the V2 upon V1? Just eliminate I1 or I2. So better to eliminate I2 from the second equations. You know that this I2 is simply minus V2 upon 100, which is minus 0.01 V2. So put this value of I2 in the equation 2, that is second equations, that is minus 0.01 V2 is equal to 0.01 V1 plus 0.1 V2, which gives you minus 0.11 V2 is equal to 0.01 V1, and finally you get V2 upon V1 as per the question, that is minus 0.01 upon 0.11, which is minus 1 upon 11. Very simple. Follow the process and you will arrive at the result. Just keep in mind that your basics should be clear and to the point what the question asked, and that comes with the practice and the procedural, that is first writing the equations, then seeing the question, manipulate it as required. Okay, let's move to the next questions. For the circuit shown below, find G12. What is the G12? Which is V2 upon V1. What is V2? Is the output voltage, V1 is the input voltage. We need to find the V2 upon V1. As usual, don't be panicked by seeing the two dependent sources, but it reduced it to a very simple straightforward equation. You see that this is the I1 coming here, and this is IA, and this is also IA, so you have twice of IA here, right? So you can write V2 is equal to twice of IA into 1 ohm, which is 2 IA. Okay, now put the KVL around the bigger loop. So when I apply the KVL around the bigger loop, that is the outer loop, because we cannot apply a KVL here because a dependent current source. So V2 plus 2V1 plus 2 IA plus 1 into IA, that is IA, minus V1 equal to 0, which gives you V2 plus V1, that is 2V1, and minus 1 V1, that is your V1, and 3 IA equal to 0. So V2 plus v1 and plus 3 ia, and ia is the v2 upon 2 equal to 0. So this is your, okay, this is your v1, no? Yeah, this is v1. So we have 5, 3 into 2, 5 upon 2 v2 plus v1 equal to 0. So v2 upon v1 will be the minus 2 upon 5, which is minus 0.4. So quite easily done. This is the typical engineering service or gate questions. Okay, just before seeing or before getting panicked by seeing the question, just try to analyze the in the mind that what has to be done and what equation or what part of the circuit has to be eliminated, like that. Let us move to the next example. For the circuit or network shown here, find the H22 in Siemens of above network, right? So this is a network you can see here, that is the pi network. Here is one pi network, here is also one pi network, two pi networks, and if you can see that they are connected, both the pi network 1 and network 2 connected in a parallel, right? First, we know that if you go directly find the H22, maybe you stuck in the midway, but it's better to follow the procedure, that is how H22 is related to y parameters, and you know that y parameters are added when the networks, two-port networks, are connected in parallel. So before going to the y parameters, let's see how H22 is defined. H22 is, okay, from the H parameters model, that is your I2 upon V2 when I1 equal to 0, right? Now come to the how H parameters is related to the y parameters. Write the y parameters, that is I1, I2 equal to y11, y12, y21, y22 and v1, v2, right? Can you see, can I relate the I2 upon v2 by putting I1 equal to 0 directly? No. So instead of doing this, I'll write the inverse of this equation. V2 upon v1 v2 is equal to y inverse, right? Y inverse I1 I2. Clear? And you know the what is the y inverse? That is the inverse of the y parameter matrix. As you know that principal diagonal elements are interchanged and the other diagonal elements are written there with negative sign and divided by the determinant of the matrix. Okay, I1 I2. Now you can see that when I put the I1 equal to 0, I will have the second equation. You write the second equation, V2 is equal to equal to 1 upon del y minus y21 I1 plus y11 I2. Okay, now put I1 equal to 0. With I1 equal to 0, you have I2 upon V2 is equal to del y upon y11, which is your H22, right? Now let us move to the find the so this is the relation. So definitely we need to find the determinant of the y, overall y parameters of this circuit. So need to find the all y parameters, and one thing is sure, that is the network is, this type of network is both reciprocal and symmetrical. How reciprocal? As you know that all passive networks are reciprocal, so by default it is reciprocal. Then how it is symmetrical? Symmetrical is the, when you bisect this network, you can easily see that both have equal composition of the network, so it is also symmetrical. So in that sense, I have y11 equal to y22 and y12 is equal to y21. So I only need to find the two parameters of the that is a pi networks. So I will find the y parameter for the general pi network of resistors R. Clear? So y11 is defined as I1 upon V1 when V2 equal to 0, that means sort it, and you can see that easily I1 upon V1 is equal to parallel combinations of these two resistors, that is because it is the conductance, so 1 upon R plus 1 upon R, which is 2 upon R. Clear? Which is 2 upon R. So and y12 which is equal to I1 upon V2 when I1 upon V2 when V1 equal to 0. So from this circuit, this we put V1 equal to 0. So I1 is equal to, that is minus I1 is equal to equal to V2 upon R. So y12 is equal to I1 upon V2, which is minus 1 upon R. Okay. Now for these networks I found the y parameters, which is 2 upon R because it is symmetrical, so 2 upon R. It is also reciprocal, so minus 1 upon R. Okay, and this is also minus 1 upon R. So YA, first top networks, the elements are all 3 and here elements are all 2. So YA will be the 2 by 3 minus 1 upon 3 minus 1 upon 3 2 by 3. Okay, then YB, when all elements are 2, that is in the pi networks all the elements are 2, that is your 2 by 2, that is half minus half minus half minus half and 2 by 2. So overall y parameters is YA plus YB, because when the connection is parallel the y parameters are added. So 2 by 3 and that is 1, so 5 by 3. Okay, so this will be the 6 minus 6 upon 5. Okay, sorry, minus 5 upon 6. So similarly here also 5 by 3 and minus 5 upon 6. This is the overall y parameters. As per the previously we see H22, we need to find the H22 is the del y, that is the determinant of y parameter, overall y parameters matrix, and upon y11. Y11 is here, and overall y parameters matrix, that is the determinant, that is 5 by 3 square minus and minus. Okay, 5 by 6 square. This is the overall del y, which is 25 1 by 9 minus 1 by 36, which is 25 36 upon 4 minus 1, which is 25 upon 12. Okay, so H22 is the del y upon y11, that is 25 upon 12 upon y11 is your 5 upon 3, that is 25 upon 12 into 3 upon 5, 5 4, which is 5 by 4, that is 1.25. So see the process. Okay, definitely it will take some times because I am explaining here, otherwise it will take 4 to 5 minutes max. Okay, so this is the process, and a thorough understanding of the topics is required. First of all, the conceptual things you must learn, otherwise just by thinking there then itself it will take a lot of time. And most important thing is the practice. Okay, learn the concept, then practice. Practice only can reduce your mistakes, and it can minimize your time and maximize your score because you are reducing the mistakes. Hopefully you have understood the concept and the question itself. So try and solve the more and more questions from previous years GATE and engineering service exam. See you in the next class.